Hi, thank you for watching. This is Olivos Motion Picture Productions Chemistry Lessons, Volume 1. And over here, as you can see, the point of this is to figure out what are the reagents to get to that product there. Okay, so there's a few things that you gotta do before anything when it comes to reagents. It's always best to have already practiced it, memorized it, know what reagents do what. So hopefully this is a review. Okay, so let's see. Okay, now in order to get to this product here, let me draw a little clearer so you could see it better. Alright, and I want to try to do this fast, and hopefully it's very informative, slightly informative for the least. Okay, so what we see here is this product here and this product here. First thing I want to do is always count the carbons. So this is 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Same number of carbons. Count it always, because even though they may look the same, it could be a whole different product just because it has an addition of 1 carbon or a subtraction of 1 carbon. Okay, so it's best to always count the carbons. All right, now how do you get from here to here, or from vice versa? Like, what are the reagents? That's the most important question that that you want to think about. But anyways, one step prior to this, when you think like that, what is one step prior to this? That's retrosynthesis. Retrosynthesis. Synthesis. Okay, so retrosynthesis. It's a nice little word to look up. You know, my definition of it. If you want to hear it out, if not, just speed through the video. But listen, this is retro. You know, I come from the hood. I come from Washington Heights. That's in Manhattan, New York. And what we do here, we do a whole bunch of things. But the word retro, from how I grew up, it's throwback. It's something that you get from a while ago, you know, like throwback retro jerseys or some retro Jordans. So it's something that's old or prior to what exists now, or before, or original. Something that's you know, from a time some time ago. So that's what we're gonna think about. What comes prior to that? Then synthesis is like a combination of things. Basically, things that you could get, that you could put together to make something. It could be synthetic, like fake, but it's makeup. It's kind of similar. So what makeup of something prior to this step will give you that. So that's retrosynthesis thinking. We're thinking backwards, in other words. So now, in order to get to this alcohol, by your knowledge of practicing reagents, you know that you're gonna need a alkene. Okay. Now, I write alkene here. Let me tell you how it's spelled. Alkene with the E. Alright, so alkene with the E. Let me just give you a little quick way that I learned it. Big shout out to Kingsborough, Hunter College, City College. Great professors. But listen here. This goes alkane. Starting off with the alkane, right? The A, the very first letter of the alphabet. This is just going to equal to a C, and then an alkene, the second letter of the alphabet. You see the E is not specifically, technically, per se, the second letter of the alphabet, but it is definitely second in terms of the alkene, and alkyne. This is 2. Okay, so being that it's second, it comes with 2 lines, also the double bond. Okay, and then the alkyne with the Y, the last one that is part of the most common type of alkynes, alkyne, is a triple bond, as you could have guessed. Okay, now, hopefully, this is what we're getting. Okay, so this is what we want. We want this alkene to get to that product. Okay, now let me draw this. Okay. So you have your alkene, and now you want to know what reagents do you use to get to that step. Okay, now steps is gonna vary. You know, you gotta know your reagents off the top of your head. It's like something that you need practice on doing. That's one of the biggest challenges of these type of problems, organic chemistry, is that you need to know the reagents, have it memorized. So, which reagents? There's a few different type of reagents that could give you an alcohol, but one specifically. Remember, you could always pause the video if you think you know it, so that you can see and correct yourself. Okay, BH3THF over, okay, giving you some time to think about it and getting it done. It's going to be H2O2 NaOH. Alrighty, so now this is one of the main steps that you have going on. There's the third step, because this is one of the last steps. Hopefully it's the third step. I'm assuming it's the third step. So you use this reagent to get to that. Okay, now, why you use this? Because this reagent causes an alcohol to group itself on the less substituted site of the alkene. Okay, now think about the alkene. Look, you get your alkene right here. Which side is more substituted of the alkene? Is it this side or this side? Yeah, you can see it's this side right here. So this is, in other words, like a tertiary area. It's not a chiral center. A chiral center has to have 4 different groups attached to it. This one only has 3. Why only has 3 and not 4? You think you see 4? Well, let me tell you. Look, this carbon right here is attached to 1 thing, 2 thing, and 3 thing. 3 things, okay? So, you know, if you want to think about hybridization, it would be sp3. sp2. Why is sp2? Because look, if you think about it, you got your 2 and then you got your s. You add it up, you have your number 3. Okay, that's how I think of it. You know, if it would have been sp3, then you know you're gonna have like 4 different groups there, and that would equal to your chiral center right there. But when we don't have a chiral center, we only have 3 groups here. You see, this bond, you may think that, oh, well, there's a double bond there. There's 4 things. No, this double bond is considered as one thing. Okay. If it was just a single bond, for instance, like right here, then we would assume a hydrogen is in the game as well. But no, there can't be a hydrogen when it's a double bond here, because that'll violate the octet rule. Okay, another thing that if you don't know it, you should keep in mind, you should try to review it. Octet rule. Which means, you know, your carbon can only have 4 things attached to it, the max 4 lines attached to it. And over here you already have 4 lines. You got 1, 2, 3, 4. Okay, so not to stress that anymore. Okay, that's why your alcohol goes in the less substituted site. It's right here. Remember, if you have any questions, you can always comment, and we're definitely trying to respond as soon as possible. You know, we are Olivos Motion Picture Productions chemistry tutors. We try to give you guys as much help and be as educational as possible. Okay, but now take a look at this. You have 1 step here. You want to go to that step there. What do you use? What reagents now do you use? Okay, so look, the difference between these 2 things, you gotta look and compare. There's a lot of comparison going on when it comes to reagents and figuring out what are the reagents. So you look, you see, you have an addition of an alkene here, you don't have an alkene here. What do? Okay, you may have already figured it out. It's elimination. Elimination. Why is it an elimination? Because elimination, what they do, okay, a little review, is that they will pull a hydrogen from a beta carbon, which is part of a leaving group. So now that you are thinking about elimination, you know you're going to need a leaving group in your product, okay? So you're definitely going to need a leaving group now. No way around it. But the question is, where do you put your leaving group? Okay, so Now, you got these, now you got this product here, which it seems to be the very first step, because it looks like you can easily get from here to here in one process. Okay, and but you still got your elimination process to think about. Okay, so what would be the reagents? Okay, so let's just use anything. Could be anything, just something that will give you a alkene and like a more substituted site. Okay, when you think about elimination, you have like two options. You have either, oh, could I use something like T-butyl? No, T-butyl, which is a guy like this, goes on the less substituted site, also known as like a Hoffman product. I draw these like little terms on the side in case ever you want to look it up. But we don't want it on the less substituted site. This alkene, we want it right here, because you could have an alkene here on this side right here. That's possible. You could definitely use a reagent and make the alkene go here, but you already have the alkene here on this more substituted site. Okay, so when you have an alkene on a more substituted site, you want to use like not a bulky base, but something that's kind of fast. So anything that's kind of fast. In my case, right here, let's use NaOMe over anything you could use. So, but let's just try MEOH. All right, and that seems that it could work. Okay, so now we already have this step here and this step here. Okay, so now that you know you're gonna be here, you're taking this alkene is coming from a hydrogen, so it's gonna be a hydrogen from here. All right, there's two hydrogens there, but you're taking that from there. Let me just draw the mechanisms for you so you can see a little more clearer. Okay, now what it's gonna do is gonna this arrow is coming from the NaOMe. Okay, and then this is gonna break and go here. Okay, so now you know you need your leaving group on that tertiary. So what leaving group could you put there? It doesn't really matter. You can put any leaving group there as long as it's like a good leaving group so it can leave. So now we could think about your first set of reagents. I'm just gonna go for 2-bromine and V. Okay, so what that'll do, that'll cause your bromine to go there. The more substituted site, and it's a strong leaving group, so it can leave fast. So now the question is it E1, E2? I'm not sure. I'm guessing it's gonna be E2. I may be wrong on that. That one part out of everything, but that definitely is something that is an elimination, and this is the mechanism for it. It pulls away, it takes that hydrogen and makes this bond flip over, causing it to become an alkene, and then this bromine will leave, and that's how you end up getting this product here, which is going then to be used with this reagent, which gives you the alcohol and the less substituted site. So there we have it. We have step 1, step 2, and step 3. In 3 easy steps, we were able to get this final product right here. Plus or minus an enantiomer, because we have a wedge here, a dash here, or either way, we have something that is racemic. So you got that OH right there. Okay, so this is how you get to that product. basically, just to quick summarize everything, you gotta think backwards. Know your reagents, know what they do, and you should be okay. So this hopefully was a review. Thank you for watching. Again, this is Olivos Motion Picture Productions Chemistry Lessons, Volume 1. And if you have any questions, just contact us, leave us some comments, and we will definitely try to respond as soon as possible. Hope that helps. Thank you.